So today we're going to study special types of patterns called sequences. And for us, we're going to think of a sequence as an ordered list of numbers. Okay, a little vocabulary here. Term is what we call a number in a sequence. Okay, what do you think A sub 1 represents?
A sub 1.
The first term. Yeah, the first term in a sequence. What about A sub 2?
Second.
The second term. What about A sub n?
Variable term.
Any term. The nth term. Okay, I just heard a couple of say, I remember doing this, and then I didn't hear the other part because I didn't want to. So this is kind of a review for some of us. So that's good stuff. All right. What is the difference between a finite sequence and an infinite sequence? Okay, what do you think, Brian?
Finite sequence ends.
Okay, good. Finite is a sequence that ends. And an infinite is a sequence that continues forever.
Because I hated that word. Finite. I can't be like finite.
That sounds even worse. Sounds like a Nazi. Finite.
How does that sound like okay?
But no, I did not ever remember doing this.
Well, good.
We did in math 1 actually, so.
I did it last year. I remember doing some of this stuff. I didn't
necessarily.
All right, the two types that we're going to study, specific types of sequences, are arithmetic and geometric. Now, with arithmetic, we'll be adding the same number every time.
I thought it was arithmetic.
Arithmetic.
Okay, does anybody remember, since this is sort of a review, what do we call that number that we add to it every time? Common. Common. Okay, I'll help you out a little bit. It's called the common difference.
Oh yeah, that's what I was going to say.
That was a lot of help.
Yep, and you use D. Good. Okay, so this one we're adding the same number every time. Okay, and geometric. Does anybody remember geometric, what we were doing? Okay, we're multiplying for geometric. Multiplying by the same number. And it has another name. It's also common. It's a common, anybody know? Ratio.
Oh yeah.
Common ratio. It's common because it's the same in between any two terms we pick. That's a common difference. It's common because no matter what two terms we pick, if we take the second one and subtract the previous one, we get the same thing every time. Every time. Okay. Now, why in the world they stick sequences in right here?
I don't know.
Think about it. Take a moment.
Sequences are. Wait, so you didn't make the sheet, Miss Wilbur?
That's not a very good thing.
What'd you say?
You didn't make the sheet yourself?
I did make this one.
Good.
Did I mess up?
I mean, you just said
Oh. I did not order the curriculum, but I did write this note sheet. Okay. Okay. I want y'all to think about these two words right here. Adding the same number every time. What kind of function is that? That adds the same thing every time. Linear. Linear because it has a constant rate of change, right? Ooh, I didn't mean to scratch out linear. Okay, what would geometric be? Exponential because we are doing what? Multiplying. And that's why they fit in so nicely right here.
Does dividing also fit into there?
Well, dividing is just multiplying by a reciprocal. Yeah, yeah. Okay. Shh. There's a lot of chit-chat going on.
We were talking about this.
Sort of.
I'd say so.
It's more of a little bit off the subject. Okay. So this is basically our get ready for it. All right, now n. I didn't put n up at the top because n is actually going to lead us into domain and range. But n can represent two things. It represents the position of a term in a sequence or the number of terms in a series. Now, this series thing is not an Acaag topic, but it is something that you will eventually do. Series just means add up all the terms. So, this is, a sequence is what we're doing though. So n can represent the position, like is it the first term, is it the second term, is it the 35th term, is it the 100th term? That's what your n would be, Doobie. N represents the position of the term. So, domain is our input, right?
Right.
Let's think about this in terms of sequences. Our domain. Our domain is the position of the term. So, is it the first term? Is it the second term? Is it the third term?
I remember.
Is it the nth term? What is the position of the term? So n would represent 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, forever. So a domain of a sequence would be what? How do I represent those numbers forever? Okay, negative infinity to positive infinity. Is there a negative 32.5th term? 32.5 term?
Possibly.
No.
Oh, so it's just a 0? No. 1.
1 to infinity?
1, 2, 3, dot, dot, dot.
Okay, so you want to write it like that. You want to go 1, 2, 3, dot, dot, dot,
Negative infinity.
to the end.
No.
That does work.
What?
That does work?
Yeah, that shows it. Or, how could we write it in words? What kind of numbers are those?
Whole, real.
It's very close to being whole.
No, I'll tell you what it is.
Integers are the negative
I'll tell you what
too,
it
so
is.
it's not that.
It's not whole.
Whole includes 0, so it's not whole. Is it on the tip of your tongue?
Integers.
No, because integers include the negatives.
Okay, is it counting them all positive?
Right. It is counting numbers, but what is the math term for counting numbers? The set of
Natural.
natural
I'm
numbers.
so good.
Okay, and natural numbers are basically our counting numbers. I wish they had just called them counting numbers because that would have made life so much easier for all of us, but they're called natural numbers. All right, so that's our domain for a sequence. It's a set of natural numbers. It is all the counting numbers. All right, our range, which is basically our output. Our range is the actual terms. So in a sequence, it's just the terms of the sequence. Okay, so we're going to do an example here.
What do you, wait, for range, what do you just mean output and then terms?
The output is the terms. So let's say it says find the first 5 terms in the sequence. So I'm going to make a little table here. Maybe. There it is. Alright, so we're going to do the first 5 terms. So 1, 2, 3, 4, 5.
7.
So if I plug in 1, I get out 7. Good.
10.
If I plug in 2, I get out 10. If I plug in 3,
13.
if I plug in 4,
16.
and if I plug in 5,
19.
19.
How do you know? Congratulations.
Because he plugged in 1. 1 times 3 is 3. 4 is 7. He plugged in 2. 2 times 3 is 6. Plus 4 is 10. He plugged in 3. Okay, does that make sense? All right, so if I just ask you for the sequence, you could just write 7, 10, 13, 16, 19. Okay, but we have to understand that this is a sequence, so our domain would be the 1, 2, 3, 4, 5, wouldn't it? Another way I could write it is, I could actually show you, my first term is 7. My second term is 10. My third term is 13. My fourth term is 16. My fifth term is 19. But no matter how I show you, whether it's as a list or where I've actually spelled out what each term is, the domain would be 1, 2, 3, 4, 5, and the range would be what? What's the output?
7, 10, 13, 16.
It was so embarrassing this week.
Okay, so do you see how this is a linear? This is linear. If we thought of it as a function and not as a sequence, it would make a straight line, wouldn't it?
It'd be like,
Yeah, it sure would. So, arithmetic sequence is represented by a linear function. Okay, now we're going to talk about two different ways we can represent sequences. Using a recursive formula, and then we're going to talk about using the explicit formula.
I remember this.
The recursive one is actually the easiest because with recursive, it is basically just a formula that is used to find the next term
In a sequence.
in a sequence. I'm not going to write that. Using
Remember this?
Yes, I told you.
Now I'm coming too.
the preceding term. What does preceding mean? The one before. Good.
Just kidding.
Okay, so what does the formula look like in terms of math?
Ma'am? 3x.
Well, it's a two-parter,
Wait, what you said?
the formula. The formula has two parts. The first part, you have to say, the first term is, and you have to tell me what it is. The first term is something. And the second part looks like this.
This is where it gets ugly.
No, it's not ugly. It's actually pretty easy. Okay, is everybody caught up with me with writing?
I am.
Okay, so the first step of this recursive formula is you got to say the first term is this. And then the second step is to say to find any term, a sub n, you take the one before it, so n minus 1, the one before it, and add the common difference.
Is the minus 1 part of the sum?
Yeah, the minus, all this n minus 1 is part of this.
How
Yeah.
come that's not what I remember?
You,
Oh,
there are
the
two
explicit,
formulas.
explicit.
You might remember the
That's
explicit
what it
one.
is, yeah.
Wait, should the n be little?
Yep, the n minus 1 is like a subscript. N minus 1 is a subscript. Okay, so here is a sequence. And the first thing we're going to do is come up with a recursive formula. So, what is the first term? Negative 3. Okay, what is 12 minus 7?
5.
5. What is 7 minus 2?
5.
What is 2 minus a negative 3? 5. So the common difference is 5. So to find any term after that, we take the term before it and add 5.
So.
And that's our formula. That's it.
What?
Takes both parts.
Wait,
First,
is it A to the subset n minus 1 or is it a n minus 1?
Okay, that's the n minus 1 is a subscript.
Oh yeah, you don't have to.
You don't do anything. That's just writing the formula. Okay, so let's say we had this 36, 30, 24, 18, ... What is my first term?
26. 36.
36.
6 minus 6.
Okay, so now to find any term after this, I take the term before it
Minus 6.
and subtract 6 from it.
I'm excited.
Why do you have to do n minus 1?
Okay, because what this means, T sub n, is to find, that's any term. Any term. N minus 1 means the term right before n. So to find any term, you take the 1 right before it and subtract 6. That's all it means. So you need both those little lines. Okay, the next one, which is the explicit formula. I know Doobie already said that's the one he knows. That's the one he remembers. But I want to show you how we get it. So just kind of deal with me for a second. Flip over to the back of your notes. This is on the back of the sheet.
This is the really long one, isn't it?
No, it's not bad. All right, what is the first term in this sequence?
2.
2. Okay, so to get the second term, we just talked about, to get the next term, I would just add the common difference. What's the common difference? 4. So is that fair to write 6 as 2 plus 4? Because isn't 2 plus 4 equal to 6? Okay, so to get the third term, I'm going to take the 1 before it, which I have written as 2 plus 4. And what do I have to do to that?
Plus 4.
Add 4.
So it'd be like.
Okay? To get the next one, I take the 1 before it, and what do I do?
Yeah, I
2 plus 4 plus 4.
Add 4. Okay? To take the fifth, to find the fifth term, I take the 1 before it. 2 plus 4 plus 4 plus 4, and then I add 4. Okay. How many common differences are there here on the second term? 1. How many common differences are there on the... Okay. How many common differences are there here? Okay, how many common differences are here? All right, how many common differences are here? 0.
I'm smart.
All right, does anybody see a relationship between the common difference and n?
Wait, what's it?
The common difference is 1 minus.
It's 1 less
minus
than
1.
the number of the term, right? So the common difference, the number of common differences is n minus 1.
So that's for everything?
Okay, so let's try to write this out now. What else does every single one of these have in common?
2.
A 2.
Yes.
All right, if we were coming up with a formula, which one of these down here represents the 2?
The first. Oh, the Hold on, nobody say it. Nobody say it.
A sub 1.
A1.
Okay, so to find any one of these, I take a sub 1 and add to it
4.
n minus 1 times the common difference.
See,
That's the one that we did last year.
To find any term, you take the first term and add n minus 1 common differences to it.
Wait, what's n?
Do you see how this formula comes from this, though? That's what we were doing.
So the n sub 1 would be like what number in the sequence it was. So if it
Right.
was like the 50th number in the sequence.
You'd plug in 50 right here, and you get 49 times d.
That's what it is.
Okay? So a sub n represents the nth term.
Ah.
A sub 1 represents the first term. N represents the number of terms. And D represents the common difference.
Oh, goodness.
Okay, now, does this problem help this formula make sense? Do you see how that formula is created? That's what we do every time. When we look at it from a recursive formula, what's happening every time? Well, I'm adding 4, then I'm adding 4, then I'm adding 4, then I'm adding 4. I'm adding that common difference every time, but if we look at the number of common differences, the number of common differences is always 1 less than the number of the term. And that's where the formula comes from. Okay,
What's 46 times 3?
so our formula is a sub n equals a sub 1 plus n minus 1 times d. Oops.
So, the common difference is 1 less than...
The number of common differences is 1 less than the number of the term.
So, if n was like 6, what would the common difference
There would be 5 common differences. Whatever they are, there's 5 of them.
So that you would put that in for
You would put, yep. You would put 6 in for n, and you'd end up doing 5 times d. We're about to do a couple examples, so hopefully it'll make more sense when we do an example. Okay, example 1. First we're going to write the explicit formula, and then we're going to come back in just a second and do the recursive. And then we're going to talk about why the explicit can be more helpful. What is the first term in this sequence? Negative 4. Okay, what is 5 minus 2?
3.
What is 2 minus negative 1?
3.
What is negative 1 minus negative 4?
3.
So what's the common difference?
3.
3. So the explicit formula is this. A sub n equals that first term, negative 4, plus n minus 1 times the common difference of 3. And there's our explicit formula.
But wouldn't we plug in 4 for n?
47.
Okay.
And
Okay, this problem asks you for 2 things. First, it says find the formula. That's the formula. Second, now we have a second part. Then, find the 47th term. So, a sub 47. The 47th term is negative 4 plus, what do we plug in for n? 47 minus 1 times 3. So what is the 47th term? Anyone? 130.
I'm not ready. Minus 4 plus negative 4.
I got 134.
I got 134.
Okay, now, just so we don't forget, let's go back and do recursive. What is the first term? I'm going to stick with it. Okay, and then to find any term after that, you take the one before it and add 3. Now, most of us can look at this and go, I'm adding 3, I'm adding 3, I'm adding 3, I'm adding 3. And I have seen people on a test do this, where they didn't bother to learn the formula, and I ask them for the 62nd term, and so on their calculator they go, plus 3, plus 3, plus 3, plus until they get to 62 times.
Or you could just do 62
Okay?
times.
Now, that is the part of the limitation of the recursive formula. The recursive formula is something you do naturally in your head. In your head, you go, hey, I can look at this and see what I need to add. That's what your brain does automatically. Now, the explicit formula gives us a nice shortcut to finding a large term. A very nice shortcut to finding a large term. You won't have time on my test to finish if your goal is to enter it 62 times. Yes, ma'am.
Kind of off topic, but are you recording?
I am.
Your microphone is going.
This microphone is showing
okay.
red.
I was looking for the other one.
Oh, no, I use a room mic. And that way I can walk around the room if I want to.
Oh, it's convenient.
It is convenient. All right, number 2. What is the first term in number 2? 25. What is the common difference? Negative 5. Good. So what would the formula be? T sub n equals
25.
25 plus n minus 1 times negative 5. All right, I heard several people go, why is it T? It was just A. Okay, you can use A or T. A is what you use when I'm basically telling you this is arithmetic. T is what you can use for any sequence. So most of the time, and on your test, I will use T. That way it's not a dead giveaway to you. Hey, this one's arithmetic.
Wait, what does the difference between arithmetic have to do with arithmetic?
Because we're going to do arithmetic and geometric. So I'll use T's for everything instead of A's and G's. If I use A's and G's, then you automatically know which one it is.
What's the difference between arithmetic and geometric?
Arithmetic is adding the same thing each time. And geometric was multiplying. Okay, so I know some of you have already worked ahead because you're bored.
But that's
And what'd you get for T T sub 100.
-470.
Negative 470. Beautiful.
I got the first time, so I know my
Beautiful. Okay,
That makes you different.
we are going to stop right here for today. The back of your warm-up is your homework.
Ah, can we go ahead and do that?
Which way is
Okay, so let's look at the back of your warm-up. The top part, you're just identifying. Is it arithmetic or not? The middle part, you're finding the 20th term. Please don't hit +5, +5, +5 on your calculator 20 times. Don't do that. Use the formula. The bottom, you're supposed to just write the explicit and recursive formulas if possible. There's one that's not possible. Okay? All right, this is quick stuff. If you work diligently, you'll probably finish before the bell.
Brian, that is my